So we are now on module 3, that is curvilinear translation. So by the end of this lesson, so we are now on curvilinear lesson 1. So we're going to talk about flight of projectiles, or we are analyzing the projectile motion. So by the end of this first lesson, you'll be able to define what is curvilinear translation. So what's the difference between this concept from the previous chapter, no, or from the previous module that we have, that is rectilinear. So what's the difference between curvilinear and rectilinear? Then you'll be able to examine the velocity and acceleration components of a curvilinear motion. So there's a huge difference on the magnitude and also the um, the direction, no, of these vectors, velocity and acceleration, in comparison to that of a rectilinear translation. And then the third one is you will be able to apply the kinematic equations in solving projectile motions. But here, for the purpose of simplicity, we neglect the effects of air resistance so that we can use these kinematic equations fully. So rectilinear versus curvilinear. On the figure at the left, this is a rectilinear motion. So we have here particle A. So it travels along the x-axis, along this one. So it moves from A to B. So it has a displacement delta x sub 1. And then from B to C, it has a displacement of x sub 2. As you notice, um, of course, the magnitude of the displacement are different from A to B and then from B to C, but um, the direction, no, for the first displacement as well as the second displacement, they are aligned to each other and they are parallel. So wala siya naka-incline, no? Wala na-incline. So if dili kay ma-incline, meaning to say kanang straight, okay? Very straight path, okay? So whereas on the right right figure, no, so this is a curvilinear translation. So this one, no, kaning oblong mo na siya nagrepresent sa object, and then sa atong object, so we represent, or um naatay gipili nga duha ka mga particles. This one kaning shaded black, o kaning nalay mga slant lines, no. So as you can see, a curvilinear motion is still part of a part of translation. It's because ang path sa kada particles kay parallel to each other, even if they travel siya at a curved path. So ang curved path ani kaning represent aning gray nga line. Okay, so as you notice, as this object travels from point A, label this one, to point B, label this one, so the displacement is shown by this arrow, no, kaning arrow, so delta s sub 1. So why is it that delta s sub 1? So why is it dili man siya delta x? Remember that the displacement of this object has already inclined, no, naka-angle na siya, naka-angle, meaning to say this one is a displacement vector. So remember sa ato ang previous nga discussion, we all know that the displacement vector delta s is equal to the sum of the vectors along x and along y. So that is displacement along x plus the displacement along y. Okay, so remember that these are vectors. Okay, so the delta x, no, delta x is this component. Okay, this one component niya along x and also along y. Okay, so again, the position of A relative to the origin we call that one as the um, position vector. So we can also express this delta S sub 1 as the position vector. So that is delta SA minus, okay, minus the position vector of B. So minus delta S B, okay. And after that, so from B to C, we have another displacement that is delta S sub 2. So delta S sub 2 can also be expressed as the difference because that is the displacement, that is final minus initial. Let me correct this one. Okay. Baliktad din siya kay difference man dahil. So starting from the final minus the initial. So that is SB, SA. Okay. So again, this is, or these are vectors. So delta S sub 2, that is the difference of the position. So position vector C minus position vector B. Okay, as you notice, the uh, the the direction of delta S sub 1, no, is not equal to the direction of delta S sub 2 because naka-incline sila, dili sila straight, no. Kung naka-rectilinear motion pa lang ni, dapat ang location sa C should be right here. Okay, location sa C. Kung naka-rectilinear nang. However, this is curvilinear, so naka-incline na po at a different angle ang kanang kuan, ang next or ang successive nga displacement. So the main difference, no, again rectilinear motion, ang ato ang displacement vector changes its magnitude, of course, naglahi ang magnitude or value, but not its inclination. So naka-align lang and they are parallel to each other, no, and they are collinear. Okay, they are collinear. So while in curvilinear motion, so both the magnitude mag-change yung value and then also the inclination. So meaning nag-usab-usab because if we have lines, no, natay mga lines nga different ang inclinations, then if maka-trace ta ani kuan kanang tangent lines, so we can create a curve. So with these lines at different angles, we can produce a curved path. So this is the basic kanang definition of a curvilinear motion. So again, magnitude and inclination changes. So next, we're going to analyze the velocity in a curvilinear motion. So let's start with this figure on the left. So we have here the position of a particle at point A. So it travels along this curved path shown in gray and then towards B. So we all know that the displacement from A to B is not this curved line, no? So again, don't forget this one, not the curved line. Why? Because the curved line represents the distance, okay? Distance. But since we're talking about displacement, so the displacement is the shortest distance. So in math, that is the chord, no? Chord, not the arc, because the arc is the distance, whereas the chord represents the displacement, delta S. Okay, so our displacement again can be broken down into components along the x and along the y axis. Okay, so from this one, no, from this one, since there is a displacement, so we can also predict its velocity because again, velocity is the change in displacement with respect to time. So on the right side, no, on the right picture, so we have here the velocity of a particle at point A. So it is represented by this letter V, no, letter V. So the velocity of this particle at an instant at a location kaning A, no, so is expressed. So velocity can be expressed as the derivative, no, the derivative of the displacement S with respect to time. Okay, so again, displacement, no, from A to B. Now the displacement can be expressed as the sum, the vector sum of its components along x and y. So we can say that that is um, dx over dt plus dy over dt. So this one represents the velocity along x and along y. So therefore, this one is vx plus this one is vy. We can put an arrow at the top to represent that as a vector. Okay, so the angle between the the kuan, the angle between the velocity component along y and the velocity component along x is represented by this angle theta b. Okay, so we have tangent, no, tangent theta v is equal to the velocity along y over velocity along x. So this is how we are going to solve for the angle, no, for the angle of our velocity. So in short, the velocity at any point along the curved path is the vector sum of its component velocities, that is along x and along y. And just remember this one, that the velocity, no, is always tangent to the curved path. So let's say, for example, if we have another location, no, let's say this one. So the velocity at point B right here should always be tangent, no? The direction should always be tangent to the curved path. Okay. So next, let's proceed to the analysis of the acceleration in curvilinear motion. So again, for the velocity, that is always um, tangent, no, to the curve. So let's consider again um, two locations of our particle. So first location is at point A, and then the second location is at point B. So at point A, it has a velocity of VA, and this vector VA should be kanang kuan tangent, no, to this curved path represented by this gray line. And then the velocity also at point B is represented by this vector VB, and it is always, or it should be tangent, no, to this curved path. Now if we are going to perform vector sum, so as shown here, this one, so let's isolate this part. So VA mo ni siya, gicopy lang, no, ang iyahang drawing sa iya vector, and also VB. So again, the resultant is drawn right here. So this is by triangular method. So this resultant is represented by delta V, or that is the change of its velocity, no? Or delta V in mathematical equation, that is that is the the sum, okay? The sum. So that is, I mean, not the sum but the difference, sorry, the difference. So that is um vector B minus vector A, or that is the final velocity minus initial velocity. And don't forget to write this one. So it symbolizes the vector, a vector. So having this delta V, so this is the resultant velocity, no? So we can also resolve this one. So we can resolve this delta V in terms of its component along Y. So kani siyang paubos. And also along X, kani siyang padulungan to. So therefore, if we have these components, then we can also solve for its acceleration. So that is delta V, instead of expressing that one as the change of its um, velocity from B to A, so we can also express this one in terms of its component. So that is component along X plus component along Y. Okay? So again, um, we can also derive our acceleration here. So that is why on the right side, or on this picture, no, shown in the right, so we have here the particle at point A, no. So how can we get its acceleration? So the acceleration is simply the uh, the sum, no, of its acceleration components. So that is ax plus ay, and we all know that the acceleration is the instantaneous change of the velocity, no? So that is derivative of the velocity with respect to time, so that is along x, plus the derivative of velocity along y with respect to time. So that is the total acceleration. So to find the angle between um, these two components of the acceleration, so let's represent that one as um, theta a. So tangent theta a is equal to ay over ax. So the difference, no, the main difference between the acceleration and the velocity is that the acceleration, no, is not tangent. So kanilang bantay is not tangent to the curved path. As you can see, the acceleration is right here, paubo siya, no? Whereas if we draw again the velocity vector at point A, patangent siya sa curve. Okay, so not tangent. And still vector sum siya. The same with the velocity vector, no? So sum sila. However, they only differ to the direction. So okay. So for the velocity, tangent to the curve, whereas for the acceleration, not tangent to the curve. It could be at any angle with respect to the curve. Okay, so let's proceed to the projectile motion because kaganiha, introductory part sa definition of the curvilinear motion and also the analysis of both the velocity and the acceleration vectors, no, in a curvilinear motion. So here, our first example of a curvilinear motion is the projectile motion. So si projectile motion under siya sa curvilinear motion. Usa siya sa mga example sa curvilinear motion. But in our discussion for today, let's neglect air resistance. Okay? So, man siya tong kuan. So, this is an ideal condition. In reality, dili ni siya di ni siya ma-realize because of course, if mag-throw ta og something sa out, especially or even if indoor or outdoor, nagid na siya air resistance, no, and it can affect both the velocity, the displacement, and the time. Okay, but not the acceleration. So let's discuss why. I mean, maka-affect siya sa acceleration, but on a particular component lang. Okay, because there is a component of the acceleration nga not affected even if na air resistance. Okay, so this is a diagram of a projectile motion. So this red curved line represents the path of a projectile motion. So example of a projectile motion, kanang mga basketball player, mag-itsa sila, no? Shoot sila sa ring. So ang path ana kay kanang projectile, no? Ang uban gi-model ang projectile og kanang parabola, no? Or any curve, no? But mostly sa mga problems gi-represent nila by a parabola, no? Paana siya. So, depende po no? Depende po na sa abang mga factors. So, here, I will show you, no? Unsay nahitabo sa object when it undergoes a projectile motion. So, let's start at the first position. So, kaning sa bottom. So, represented by point O or point 0. So, of course, nana siya initial velocity. And since this one is traveling in a um two-dimensional nga kanang kuan plane, so we have along x and along y, so therefore it has a velocity component along y voy and also along x vox, and of course it has a displacement relative to any reference line, no, or let's say at the origin, and also along x. So nana siya displacement. So as it travels upward, no, as it travel on the second position, number one. So at that point, no, number one, of course, nana po na siya corresponding nga velocity along x. So ang nahitabo sa projectile di ay mura siya og na ay movement along x and also movement along y. Okay? So na siya vx1 also displacement. And on the second position, so ni-move na pod siya, more siya ni-move pataas, so represented by Vy2 and also its displacement, and then also along x, so ni-move pod siya, no, represented by Vx1 and delta x2. Okay, so at point 3, so ni-move siya pataas, so represented by velocity Vy3 and also its displacement, and the same thing along the x axis. So sa kuan sa iyahang vertical na component, no, there is an acceleration that uh, took place, and that is the acceleration along y, which is also equal to the gravity. So ang main nga nakapag-influence sa pag-usab sa velocity sa atong object, no, undergoing projectile motion is the earth's gravity. If wala gravity, of course it will kanang ano, move upwards, no, why katapusan magsigirag taas. But since na may gravitational attraction, so this g, no, that is the earth's acceleration due to gravity, so ni accelerate ang ato ang object pa downward. So if our motion is against this one, so we are expecting nga mo reduce ang atong velocity as we go higher and higher. Okay, whereas along the x-axis, no, our acceleration here is equal to 0. So meaning constant ang velocity along the x component, so that we can have this perfect curve, no? Perfect projectile curve. So mahitabo ra ning acceleration along the x-axis equal to 0 if air resistance air resistance is equal to 0. So, more na inyo ang hinumduman. If there is an air resistance, so meaning nanapoy acceleration along the x component. Okay, so let's have some formulas in order to quantify projectile motion. So, along the x component, we assume that the acceleration is 0, and also the velocity of this particle along x is equal to its component, no, so we have here theta, so therefore x component man siya, no, if we draw a triangle, no, so this is our theta, this is our initial velocity, so therefore this is our vx and this is our vy. So our vx is equal to the initial velocity along x, that is also equal to v naught cosine theta. Okay, so therefore even if nata diri ano at point b natay vx diri so the vx here, the velocity at point b along x is the same as the initial velocity because there is no acceleration. So that is why vx is just equal to the initial velocity. And then the displacement is simply equal to the product of the initial velocity, no, times the time. What siya acceleration? So for the x component of the projectile, simple lang ang mga formulas. However, on the y component, since there is an acceleration which is equal to the negative g, so negative siya because we assume that this acceleration acts downward. Okay, so negative siya. So therefore, the initial velocity along the y is equal to v naught or initial velocity times the sine of theta. And then if you want to know the velocity component along y at any point, let's say for example at point B, naman na siya Vy dira so that is equal to Voy minus GT. So asa ni siya gikan, sir? This is from the kinematics equation that we have just or that we have discussed na from the previous lessons. So ay ito kalimti. And we all know that Voy, we can represent that one as V naught sine theta. Okay? Kamo na lay derived niya na. And then for the displacement along y, so that is equal to v naught yt minus 1 half gt squared. And also the last or the third kinematic equation kasi kay di ba tulo ra to akong discuss kaning tulo importante. So the third one is the square of the final, which is equal to the square of the initial minus 2g change in displacement. Okay, So ang iyang resultant velocity and angle of inclination phi can be expressed by this one. So let's say for example, if we want to know the velocity of the particle at this location, let's say this location is represented by point P. So if you want to know the velocity here, so represented by V, so just saman, if we know the magnitude, the magnitude, so ato na ikuan magnitude ni siya. So that is just the square root of the sum of the squares of its velocity components, that is along x and along y. And then for its angle, so ako na siya represent by phi in order to avoid confusion sa theta diri because ang theta, we use theta to represent the angle, no, at the initial position, whereas the phi, this angle phi represents the angle of the velocity at any location along the projectile curve. Okay, so tangent theta phi is equal to Vy over Vx. Okay, so any questions so far? Nakaapar sa class? Kapasa? Okay, so proceed sa problems, no? So let's apply these kinematic equations to solve different problems relating to projectile motion. So we have our problem number one. So a projectile daw is fired with an initial velocity of 193.2 feet per second upward at an angle of 30 degrees to the horizontal from a point 257.6 feet above a level plane. What horizontal distance will it cover before it strikes the level plane? So this is the figure, no? So we have here a particle, no, shown by this shaded circle. Of course, it has a initial velocity v naught, and that is equal. So let's just write here the given. The initial velocity is 193.2 feet, and then we also have the angle of inclination at the initial position, that is equal to 30 degrees. Okay, and also um, we also have a displacement along the y-axis or along the vertical, that is 257.6 feet. Kaya naingon man siya diriya, that is above a level plane. So therefore, let's assume that this line, horizontal line, represents our level plane. So our delta y is understood to be equal to 257.6 feet. Okay, this delta y right here. And then, okay, next is the required. So we are to solve for the displacement along the x. Okay, so since mao na ato ang gipangita for our solution, so we find a kinematic equation that contains this variable delta x. So this is from the x component, no? If we move back sa atong slide, okay, kani siya. So kaning last, no? Siya ang naay delta x na variable. So balik ta. So for our solution, we have delta x is equal to v naught initial velocity along x times the time. So from this formula, we need to find, no, we need to look for the initial velocity along the x component and also the time of flight, no, that is from here to here. Okay, this is our initial position, and then this is our final position. So we can also express, no, our initial velocity component along x as the initial velocity times the cosine of theta and then times the time. And after that, um, since in this equation we cannot proceed, no, to the final answer because we lack an information for the time, so we don't know the time yet. So we need to find another kinematic equation that contains the time and the other given variables. So mo proceed daw ta sa y component. So in the y component, we have this kinematic equation for the displacement along y, that is delta y is equal to VOY t minus 1 half gt square. Okay, we have this one. So we all know that the delta y is given 257.6 for VOY given then, and also the angle. So, and also, of course, g is constant. We already know that one in English, that is 32.2. So with this, we have one equation and one unknown, that is t. However, this equation is a parabolic equation or a quadratic equation because the degree is equal to 2, so t squared siya. But it's okay because we can use quadratic formula or through our scientific calculator. Now in solving projectile motion grid class, if you are utilizing the kinematic equation, make sure to indicate the sign, no, because tanan nga naa diri except for the time, no, and also for the acceleration due to gravity g, kay nakaset naman siya, that is why negative diri because i-assume nga this is downward. So except for g and t, both the initial velocity and the displacement, no, should follow sign convention. So if the velocity is upward, assume positive. If the initial velocity is downward, negative na siya. The same thing with the displacement. If the displacement if is upward with respect to the initial position, you take the positive sign. However, if your displacement is below the initial position, you take the negative sign. So in our problem, delta y is below the initial position. Paana siya. So therefore, our delta y here should be negative. Okay, so negative 257.6 is equal. Now VOY, we can express that one as VOY is equal to VO sine of theta. Okay, so here butang nato, that is 193.2, and then we have sine of 30 degrees, then t minus 1 half, tapos 32.2, and then we have t squared. Now let's rearrange this one, no, in order to arrive a very um, nice quadratic equation in standard form. So let's transfer this one, no, para ma-positive ay first term. So we have 1 half times 32.2 t squared, then also this one. So we have minus 193.2. This is sine 30 degrees t, and also the last one minus 257.6 equal to 0. Okay, so we have two values for our time because this is a quadratic equation. So we can use our scientific calculator, cycle. So sa ato cycle, go to mode, choose equation 5, and then choose number 3. So ato input ang mga coefficients. For the first term, we have 1 half times the acceleration due to gravity, 32.2. And then for the middle term, we have negative 193.2 sine of 30. Okay. And then press equal sign, and then we have negative 257.6. So another equal. So we have time 8 and negative 2 seconds. So we have 8 second and then negative 2 second. Of course, positive ba to equal because this one is absurd na siya. Okay? So we're going to use the positive time. So for the next slide, we're going to solve for the delta x na because we already know the time and then given naman ang theta and also the initial velocity. So therefore, we have our delta x is equal to v naught cosine of theta times the time. So our initial velocity again is 193. So we have 193.2. This is cosine of 30 degrees, and then let's write the dimension of it per second, and then for the time we have 8 seconds, so therefore makancel ang second. The result is in feet. Okay, so in our calculator, go to mode, return to computation, no? So comp number 1, then perform this one. So 193.2 times cosine of 30. So if you are dealing with trigonometric identities in your cycle, make sure nga coherent ang imong pag-set sa angle, and also the and also your setting. So setting dira is naka-degree siya. So times 8. So the result is 1338.53. So 1338.53. This is feet. Sa libro ni Singer, ang iya answer dito is 1340. So close lang, no? 1338.53. Okay, so any question so far for our first example? Okay, I think na nag-type. Ay, okay, si Mateo. Sige, go ahead, Mateo. Again. Kanus sa gamiton? Yes, oh. Yes, oh. Kung positive ang duha, i-try sila. I-try ang duha. I-try ang duha. Oo. Tapos, nagiusa na nga mulahi gyud iha answer. No? Labi na kay this one, you already know the direction of delta x. No, if ever no possible, no, positive ang duha ka time. So try the higher one, and then imo jud na kailangan i-interpret, no, if ever your displacement delta x is kanang kuan, if that is positive, so okay to siya nga time, because of course nitro gug ka padungad to, no, padungad to. So kuan gid na positive imo x. However, if mo contradict siya, mag negative siya, so therefore sayop na siya nga time, no. So usa ra gid ani ang mo kuan, usa ra gid ang mo agree ani. Oo, sa ato ni example, swerte, no, kay the second root is negative, so there is no negative value of time, so therefore use the positive. Okay, ang uban naway pangutana. Okay, wala. So let's proceed to the second example. So the car shown in the figure below is just to clear the water filled gap. So find out the takeoff velocity. So takeoff velocity, it means the initial velocity. So natay car, no? Nidagan siya ng inclined plane, inclined at an angle theta. I forgot to put the value for theta. So sa book, that is equal to 30 degrees. Okay. Angle theta is 30 degrees. So midagan daw siya, and then the height of this one, kanang inclination is 22.2 feet relative to this horizontal plane. So naa siya water filled nga gap. The width of this gap is 17.32 feet. Kailangan inigmulayat siya, no? Di siya mabuasot sa kaniyang water filled gap, or unsa ba kan siya, kanang kanal ba ni nga dako, or sampa ba, or whatever. So kailangan siya makaambak lang gid nga maabot siya ani nga part. And that motion, no? Syempre, di man ni siya pwede mo ana iya motion mo ana tapos mo ana. Of course, in a natural sense, ang path gid niya, no, because of its weight, no, and due to the earth's gravity, so it follows a projectile path, no, projectile motion gid ang iyahang masunod niani. So for this, let's write the given. So given ta og angle, no, at the initial position, that is 30 degrees, and then we have delta y. Okay, so since our initial position is right here, okay, at the tip ha, ang atong analysis mag-start at the tip, not below this incline, so right here. So therefore our displacement along the vertical component is below the initial position. So this is our initial position, and then this is our final position. So since ang delta y is below, so we treat that one as negative, so negative 22.2 feet. What else? We also have a displacement along x, no, or along the horizontal, this one right here. So we have delta x, and since our delta x is towards the right, no, so nasa sa right with respect to the initial position, so therefore we treat that one as positive. So 17.32 feet. Okay, I think more nang given, and then the required is, so the required is the initial velocity v naught. So kanisiya gamit ang given, and then based akong discussion daghang itong mga kinematic equations. So the main challenge here is to look for a kinematic equation that will combine this given parameters and also the required variable. Mo na siya imong challenge dira. Okay, so for our solution for this problem, so we all know that, I mean, the initial velocity, no, can be solved either either using the x component formulas or the y component formulas. So let's try the simplest option, that is along the x component. So along the x component, we all know that the initial velocity along the x component is equal to the displacement over time. Okay, or we can express this one as the product of initial velocity times cosine theta, which is equal to displacement over time. However, if we're going to use this equation, we only have delta x, what type value sa initial velocity, kay mao man na siya required, as well as the time. We don't have value for the time. So we need to find another kinematic equation, no? So that at least man lang usa sa ila ato makuha. So we can also use the displacement, no, the displacement formula from the y component, no, and let's see if na ba tayo makuha. So from the y component, the kinematic equation that we're going to use is the displacement equation. So the displacement equation along the vertical component is, we have delta y equals voy t, okay, tapos minus 1 half, and this is gt square. So given ang delta y, voy can be expressed as v naught. This is sine of theta. So given ang theta but required ang v naught. For the time, wag gihapon. So therefore, kuwang ni og time. In this part na ay time, so maybe we can combine the time, no? We can solve for the time here kaning sa x component, and then plug the result to this one sa kaning delta y. And in that manner, or in that way, we can eliminate the variable for time. So time is equal to delta x all over v naught cosine of theta. So we can plug this time right here so that ma-eliminate na ang variable nga time. Okay? Para initial velocity na lang ang mag magpabilin. So solving for v naught. So let's combine. We have delta y is equal to, we have v naught sine of theta, and then for our time, that is delta x all over v naught cosine of theta, minus we have 1 half g tapos t square, so that is delta x v naught cosine theta, and then that is square. Now, if we're going to simplify this one, so v naught ma-cancel, so therefore we only have delta x, and then sine theta over cosine theta in your trigonometry, that is equal to tangent of theta. And then on the last term, so we have 1 half g. In the numerator, we have delta x square divided by this one. So we have v naught square and then cosine square theta. So this equation that we have just derived, this is also known as the general equation for projectile motion. So general equation for projectile motion. Okay. So kani during my kanong board exam nga review, so ako nang gibalik-balik jud og familiarize kay by having this one, it is already enough no para makasolve ka og mga projectile motion problems. Okay? Kay if di ka makaibaw ani, medyo mo take pa siya kanang extra time no to derive this general equation for projectile motion. So by this derivation, but by having this one, so pwede ka nilang inyong i-familiarize. But of course, mas maayog kay ba ka sa derivation kay if ever makalimtan no, kalimtan ba tungod kadagan sa formula. So mas maayog kay ba ka mo derive. Okay? So since for this general equation for projectile motion, given ang uban nga mga parameters, so we can solve directly for the initial velocity. So ato lang siya i-modify. So diri as sa next slide, ato i-rewrite ang general equation, the delta y equals delta x tangent of theta minus 1 half g delta x square tapos v naught square cosine square theta. So we can transpose this one on the other side and also delta y on the other side. So we have 1 half g delta x squared v naught squared cosine squared theta, that is equal to delta x tangent of theta minus delta y. Okay, so we can exchange the position of this one and also this one. So um, we have v naught square equals g delta x square all over 2 v naught square times delta x tangent of theta minus delta y. Okay, so take the square on both sides. So we have v naught equals, sa delta x lang ang ma-extract no, and also, ay sorry, no need to write v naught, nadubli-dubli na lang, so sorry. Can you see, what na siya? Okay, so just kanara. Okay, so I forgot to put the cosine theta. So 2 cosine squared theta. So with this, ma-extract ang delta x ano sa cosine theta kay mga squared sila. So we have delta x all over cosine of theta tapos square root of we have g over 2 times delta x and then tangent theta minus delta y. Okay, so let's plug in the values. Our delta x is equal to this, so we have 17.32 all over cosine, this is 30 degrees, and then square root. Okay, so the acceleration due to gravity g is 32.2 divided by 2 times the displacement if positive 17.32 tapos tangent of 30 minus our delta y here is negative, so ang minus 3 ma-positive na kay minus minus man or minus negative, so plus na siya tapos 22.2. Okay, so our initial velocity di is equal to, so ato gamit og calculator, but first let's simplify the expression inside this radical symbol. Okay, para di mag-loading ang calculator. So 32.2 divide by 2 times 17.32, tapos tangent of 30, and then plus 22.2. Okay, so equals, and then take the square root, so square root of answer, we have this, and then answer times this one, 17.32 divide by cosine of 30. Okay, so the answer is 14.142. So approximately 14.142, this is feet per second. Okay, so this is the takeoff velocity of our car. So any question with regards to our second problem? Naipangutan na? Okay, wala. So let's proceed, before we end this one, let's have the final example. So we have a ball is thrown so that it just clears a 10 feet fence 60 feet away. So if it left the hand 5 feet above the ground and at an angle of 60 degrees to the horizontal, what was the initial velocity of the ball? So the illustration for this problem is shown right here. So we have a boy holding a ball, no? So ang iyang hand, the location of its hand, the position of its hand, wherein nagunit siya og bola, is 5 feet above this horizontal ground. So, ground ni siya. No? So, 5 feet. And then, um, 5 feet, no? 5 feet, let's call that one as given. We have delta y1, that is 5 feet. And then delta y2, that is the height of the fence, also 10 feet. And then, the distance of the boy relative to the fence is 60 feet. So delta x is equal to 60 feet. Okay. So the angle, no, of the initial velocity vector relative to the ground or relative to horizontal is 60 degrees based on the problem. So our theta is equal to 60 degrees. The required here is the initial velocity. So v naught. Okay. Now, we have two displacement along the vertical. However, let's redraw this illustration, no? So that we can simplify the the projectile motion that happens. So let's say this is the position of our ball, and this is our ground. So from this position towards the ground, 5 feet, and then the height of the fence is equal to 10 feet. No, this is 10 feet. Now, if we draw a horizontal reference line at the ball's position, so man ni siya, kay naka-hidden lines, and then nadara ang iyahang initial velocity. And with this initial velocity, no, ang bola, di siya maigo sa fence. Bali, muluwak lang siya ani nga fence. Okay? So therefore, we need to know this effective height, no? Delta y. Let's represent that one as delta y lang. And then this is our delta x. Okay? We know that delta x is equal to 60 feet. So therefore, to solve for delta y from this illustration, no? From this illustration, delta y is equal to the difference of the height of the fence and the height of the ball relative to the ground. So that is delta y2 minus delta y1. Okay? And that is equal to 5 feet. So that is the effective displacement that we are going to use in our calculation. So again, required gihapon ang initial velocity. This is a problem, no, similar problem from the previous one. Okay, nga define gyapon initial velocity. So for our solution, mangita ta og kinematic equation nga mag-relate sa ato ang required nga initial velocity with respect to the other parameters. So let's start with the x component. So we all know that initial velocity along x is equal to the displacement over time. Okay, and then also we can use the displacement equation from the y component, no, because na may time pud nga to and also displacement and also the initial velocity. So we have delta y equals initial velocity along y t minus 1 half g t square. Okay, so duhay unknowns na yan, you know, initial velocity and also time, and on the right initial velocity and also time. So we can substitute the value of t on the first equation, and then we can solve for t on the first equation. Let's say this is equation 1, and then use that one, or substitute the value of t at the first equation, substitute that one to equation 2. So time is equal to delta x all over the initial velocity component along x can also be expressed as the product of the initial velocity times the cosine of theta. Okay, mo na siya. So we can use this expression at i-plug in diri sa time for the second equation, and then solving for the initial velocity. Okay, so that is delta y is equals to this is v naught sine of theta, because the velocity component along y can be expressed as v naught sine theta, and then the t is delta x all over v naught cosine of theta. Okay, minus 1 half g tapos this is delta x, and then v naught cosine theta, and then this is square. Now kani siya nga equation nga itong gina-derive karon. This is similar sa previous. So gamitan na lang to, no, so that dili ta malangay. So by using this one kay sa previous, so okay, nag-derive man ta diri ang apart. So by using this, we can arrive an expression for the velocity. Okay, so our velocity is therefore again same sa previous nga problem, that is equal to delta x all over cosine of theta, no, square root of g all over 2 times delta x tangent of theta minus delta y. Okay, so plug in the values. Our delta x here is 60 feet, so 60 all over cosine theta, theta is 60 degrees, the square root. So the acceleration due to gravity value that we're going to use is the English one, because ang mga given dira kay mga English pod feet, no, second pod. So use 32.2 divide by 2 times the delta x is 60, so 60 tangent of theta still 60 minus delta y. So our delta y, since iya direction is pababaw, no, so iya position is pataas with respect to the initial position, so therefore positive siya, so minus positive delta y. So our delta y is 5 feet, so minus 5. So our initial velocity, so we can use our scientific calculator. Starting with the inner part, so 32.2 divide by 2 times 60, tapos multiplied by tangent 60, then minus 5. Okay, so muna yung answer, take the square root, so square root of the answer, and then multiply this one with the quotient of delta x and cosine theta. So delta x is 60 all over cosine of 60. Okay, so the answer is 48.41 feet per second. So 48.41 feet per second. Okay, so this is our final answer. Okay, so before na mag-question, let me end na lang sa recorded video ha.